Alright, I have a feeling this integral is going to take a while, but let's try solving it. And this was only the easy integral on dailyintegral.com. So first thing I notice is I have a sine to the 4th x plus cosine to the 4th x. And I'm going to try and want to, simplify that in some way. So first thing I'm going to try and do is realize that sine squared x plus cosine squared x equals 1. And now I'm going to square both sides. And when I do this, I get, so this is going to be sine to the 4th x plus sine squared x cosine squared x plus another sine squared x cosine squared x plus cosine raised to the 4th x equals 1. And now when I solve for sine to the 4th x plus cosine to the 4th x, I get sine to the 4th x plus cosine to the 4th x equals 1 minus 2 sine squared x cosine squared x. So that right there is my identity. So now I can say I have the integral from 0 to pi over 2 of sine of 2x over 1 minus 2 sine squared x cosine squared x dx. Okay, now let's think about what I can do here. So one other thing I know is that sine of 2x equals 2 sine x cosine x, okay? And with that knowledge, what if I try and let u equal sine squared x? Because if I were to let u equal sine squared x, well, then the derivative of that is 2 sine x cosine x. So let's try and do that. So I say u equals sine squared x, and then du dx equals 2 sine x cosine x, which, if I want to, can express as sine of 2x. And therefore, dx equals du over sine of 2x. Now look at how helpful this is going to be. So this is going to become the integral from sine squared of 0. It's just going to be 0. Sine of pi over 2 is 1. 1 squared is 1. And now notice my sine of 2x's cancel out, so I get 1 over 1 minus. Now I let u be sine squared, so now I get 1 minus 2u cosine squared x du. But notice the problem we have. We still have that cosine squared x. But remember what we set u equal to, sine squared x. And sine squared x is simply equal to 1 minus cos squared x. So if I want to express cosine squared x in terms of u, all I'm going to have to do is say now that cosine squared x equals 1 minus sine squared x. So then cosine squared x equals 1 minus u. So now I get the integral from 0 to 1 of 1 over 1 minus 2u times 1 minus u du. Now I can distribute, and I get the integral from 0 to 1 of 1 over 1 minus 2u, and then plus 2u squared du. And now I'll write this in the common form that we usually see, 1 over 2u squared minus 2u plus 1 du. And now notice, I'm going to try and complete the square, and maybe I can get this into arctan form. Let's try that out, because there's no easy way I can factor this. So let's try using completing the square. So first thing that I can do is I can factor out a 2. So I get the integral from 0 to 1 of 1 over 2 times u squared minus u plus 1/2 du. And now I'm going to complete the square inside here. So this is going to become And really, I should leave out the 1, so I'm going to get 1 over 2 times u squared minus u, and then just keep that plus 1. And now when I complete the square, this is going to be the integral from 0 to 1 of 1 over 2 times u minus 1/2 squared, right? Because that will stay the same. And then also notice what I'm introducing. So whenever I square this, I'm going to be introducing, let's see. So that's going to be introducing a 1/4, right? Because negative 1/2 squared is 1/4. But then I'm also multiplying that by 2. So really I'm introducing a 1/2 in. So I have to subtract a 1/2 back out. So now I have the integral from 0 to 1 of 1 over 2 times u minus 1/2 squared. And then this is going to be plus 1/2 du. Okay. Now let's see what I can do. Well, I can say that I can factor out a 1/2 from this whole thing. And this becomes the integral from 0 to 1 of, okay, bear with me. So this is going to be 1/2 times 4 times u minus 1/2 squared plus 1 du. And remember, this is still all over 1. I forgot to put that. And now, notice that I can factor out this 1/2, so take it out of the integral sign to get 1/2 integral 0 to 1 of 1 over 4 times u minus 1/2 squared plus 1 du. And now what I'm going to do is, let's pick another variable. Let's just say t. I'll let t equal 2 times u minus 1/2. And then dt du is going to be equal to 2. And therefore du equals dt over 2. So now I can change my limits again. And this is going to become, let's see, so when I plug in 0, I get negative 1. So I get, and actually, sorry, this 1/2 here should be really 2 because that's in the denominator here. So sorry, that's 2 right there. I just noticed that. And now this 1/2 here is going to cancel with that 2. When I change my integral bounds, I get the integral from, this is going to be negative 1 to 1, right, of, and now this is going to be 1 over 1 plus t squared. Finally, look at how nice this is. So now this is arc tan t from negative 1 to 1. Okay, well now all we just have to use is integration. So I just really am plugging in. So I get arc tan of 1 minus arc tan of negative 1. Okay, so let's think about when tangent is equal to 1. Well, that's going to be at pi over 4. And then when is tan equal to negative 1? Well, that's going to be at negative pi over 4. And therefore, this is equal to pi over 2. And finally, as a final statement, we can say the integral from 0 to pi over 2 of sine of 2x over sine raised to the 4th x plus cosine raised to the 4th x dx is equal to pi over 2. Wow, that problem right there is pretty difficult for the easy integral. And that's everything we use to solve that. So, amazing problem. And stay tuned because I will next be doing the medium integral. All right.